Vector addition is one of the basic operations in linear algebra. Let's see how we can add vectors in linear algebra and review it in geometric space. Also, visualize this operation in Python. Vector addition is one of the operations in linear algebra that we need to perform an important check before actually doing it. And the check is about the dimensionality of our vectors. In this check, we need to ensure that our vectors have the same dimensions. If the dimensions of our vectors are not the same, we cannot perform addition between them. But if vectors have the same dimensionality, we can perform addition simply by adding corresponding elements of the vectors. The requirement for equal dimensionality is exactly because of this reason. We need vectors with an equal number of elements to add them together. But what about adding two vectors in geometric space? To add two vectors in geometric space, we need to place the tail of one vector at the head of the other vector. And then you draw a new vector, starting from the tail of the first vector and ending at the head of the second vector. And it's the result from addition of two vectors. It doesn't matter which vector you select to place at the head of the other vector. The result of the addition doesn't change. In this example, if I place vector k at the head of the vector v, the result from the addition of these two vectors doesn't change. This is the rule for finding the addition of vectors and can be applied to all vectors with any magnitude and direction. As you can see in these examples, we always need to place all vectors one after another and draw a new vector as long as our vectors. Also, it doesn't matter if you have more than two vectors. For example, if you have three vectors, you simply place the tail of each one at the head of the next vector. And finally, draw a new vector starting from the tail of the first vector and ending at the head of the last vector. And it's the result from addition of three vectors. But how can we subtract two vectors? Two vectors like v and w. To subtract vectors, we can easily consider subtraction as the addition of vector v and minus w. We learned how to scale a vector using a scalar number like -1 in the previous video. Now we can use it to scale vector w by -1. We can easily multiply -1 by each element of vector w. And then add two vectors to each other. In geometric space, we know scaling a vector by a negative value like -1 reverses the direction of the vector, but the magnitude of the vector doesn't change. After scaling vector w by -1, we can easily place the tail of this vector at the head of the vector v and draw a new vector which starts from the origin or tail of the first vector and ends at the head of the second vector. This new vector represents the subtraction of vector v and w. Another way to calculate the subtraction between two vectors in geometric space is to draw a new vector from the head of the second vector, or in this example w, to the head of the first vector, or v, and move this new vector to the origin. These new vectors represent the result of subtraction of v and w, which is identical to the previous approach. Now we want to plot the addition of two vectors in 3D space using Matplotlib. So the first step is importing the packages we need. We need Matplotlib for plotting and NumPy for handling our vectors. After importing the necessary packages, I define my vectors using NumPy. Two vectors v and k, both in 3D space with 3 elements. Also, I define the origin, which is the origin of my vectors. Next, we'll create a figure and a 3D axis to plot our vectors. This is done using Matplotlib's figure and add subplot function. Using figure, we create a blank canvas or window where you can draw your plots. It returns a figure object which we store in the variable fig. Also, using add subplot method, we add a subplot to the figure. A subplot is a smaller plot within the larger figure, allowing you to create multiple plots in one window. I add some options to add subplot method to configure my plot. With the number I input, I create a grid to draw my subplot in this grid. The first one means there is one row of subplots in my figure. The second one means there is one column of subplot. The third one means this is the first and only subplot in this grid. In fact, we create a subplot to contain the entire figure. Also, setting projection to 3D specifies that the subplot should be a 3D plot. By default, subplots are 2D, but setting projection to 3D tells Matplotlib to create a 3D axis. Next, we'll draw the first vector, which is vector v, using quiver method. The quiver method in Matplotlib is used to plot vectors as arrows. So I use x, which is my subplot, and use quiver method with some options to draw vector v. The first option is asterisk origin, which is used to unpack the origin list. This means that instead of passing the list as a single argument, it passes its element as separate arguments. These represent the starting coordinates of the vector in the x, y, and z dimensions, respectively. Similarly, in asterisk v, the asterisk unpacks the array v, passing its element 1, 2, and 3 as separate arguments. Also, set the color to R specifies the color of the vector, which is stand for red. Last option, arrow length ratio, controls the ratio of the arrowhead size to the length of the vector. And same process for the second vector, which is vector k. But this vector will start from the end of the first vector, which is vector v. And also, the color is set to blue. To find the resulting vector of adding v and k, we simply add their components together. Let's calculate the resulting vector and plot it. So I define a new variable, result of addition, and set it to k plus v. And again I use quiver method to draw result of addition vector and set the color of it to k. And I'll add annotation to my vector for clarity. I use text method and inside it set the location of my text, set the actual text, and the color of it. Finally, let's set the labels for the axis and define the limits to make our plot look neat. Now we'll show the plot when we run the script. We'll see our vectors and their addition visualized in 3D space.